Hello everybody, welcome back in today's video of 10-minute series. In today's video we'll be covering HYDRA power plant in easy language. If you've ever thought about how water and electricity is generated, this video is for you. So let's begin. I'll also be teaching you with the drawing, so it might be slightly time consuming but worth it. I'll first draw. So this is going to be layman's drawing, very simple random drawing, not too artistic. If there's like any drawing mistake, please I'm sorry. I'm trying, okay. I'll explain you the parts in a while. With labeling I'm going to explain. Just give me some time. Right, we are done, so let's start. I've done very simple drawing, so let me start explaining you guys now. So what you can see here, I just changed color. What you guys can see here, this is the dam and this is the reservoir, right, where the water is stored here. This is basically water source, right? And this what level you call, this is known as head water level. Head water level, this pipe, what you can see, this entire pipe, that is known as the penstock. This is like basically like pipe, cement pipe, right? And water basically flow here, so I'll just write here water flow. I'll explain the mechanism also, just give me some time. This is known as the gate, which can be opened and closed for the water flow. This is known as surge tank. This is pressure tunnel. Then you have this penstock, all this penstock. This is known as inlet, which leads to hydraulic turbine. This is known as draft tube, and this is tail water level. And I'll explain you why the arrow mark. Water flow protects the shaft, that's why. This is generator. This is, okay, I missed one box. I tried to do something else only happened. I'll just complete this however it is. I'm sorry, the diagram is a little too ugly, but whatever, the concept is important. This is control room. This is transformer. This is electric cable, power lines, grid, okay, all that. So now let me explain you. Now that we have finished labeling, now I can explain you how it works. So firstly, we all know that the water is stored in the, let me just try to change the color real quick. We all know water is stored in dams, reservoir. We all know that. Now, preferably, we saw headwater level and tailwater level, right? As you can clearly see, the visible distance is there. If there's a distance, if the larger distance between headwater level and tailwater level, higher the distance, so technically more is the potential energy, and so more electrical energy can be produced. Let me just give you the overline of this. From here, potential energy is converted into kinetic energy. Kinetic energy is converted into mechanical energy, and mechanical energy is converted into electrical energy. That's the flow. So headwater level, water flows through this penstock or the cement pipe. Water flows through this. The gate or the valve opens or closes. If it's opening, then the water can flow through it. It goes to the pressure tunnel and then to the surge tank. It goes to surge tank when the pressure is too much. It goes to surge tank so that the pressure of the water can be reduced little. Okay. Then it goes to the inlet. The inlet opening leads to the hydraulic turbine. So what happens is that, just try to imagine this. This hydraulic turbine, imagine these are like the buckets. Okay, so when water falls on these, right, when water falls on these rotate like this. So this causes the production of mechanical energy. This shaft which is connected to the what? Generator. So when water falls on this, the water flow rotates the shaft, which rotates the generator also. And this mechanical energy is converted into electrical energy with the help of generator. So first, initially, because of the height difference and all that, here potential energy was there. When the water starts to flow, it has kinetic energy. When the water hits the blades or the turbine, that time it starts to rotate. Turbine starts to rotate. Shaft also rotates. Turbine rotation causes mechanical energy to be transmitted. Now that is connected to the turbine is connected to the shaft, the generator. Generator converts mechanical energy to electrical energy. Via the control room, electrical energy is given to transformer for step-up transformer for increasing the voltage for transmission, and that is sent to the cable, wire or transmission lines and all of that, and hence it reaches to our homes like that. So basically, water is stored in dam, valve or gate. When releases water, that tunnel is there made of penstock, that is cement pipe. To bear the pressure of water, this is connected to the hydraulic turbine, right? To bear the pressure of water, this is there. Now this is connected to the hydraulic turbine. Now water released from the top is released at tail level. One more thing is, whatever water is going through this, it is also released over here. Why is water used? It is only used to generate that from kinetic energy to mechanical energy. It is to help it turn, to help the turbine to rotate, to help the shaft to rotate, to help the motor to rotate. For that only water is used here. So water is stored in dam, I told all that. Water released from top is released at tail water level. Turbine and electrical generator are coupled, same shaft connection. This is connected to transformer and towers. So basic working is about potential energy converted to kinetic energy, converted to mechanical energy, converted into electrical energy. Energy associated in water in dam is potential energy. To increase potential energy, increase height of the dam, obviously, because mgh, right? Remember potential is mgh. So on releasing water through gate, potential energy converted to kinetic energy, that is the water flow. In surge tank, area is more, so pressure of the water will help in decreasing the pressure of the water, so the pipes don't break down. This is directed to hydraulic turbine. This is the rotating part which is converting kinetic energy to mechanical energy. So water released by penstock strikes the bucket that helps rotate this turbine. So it's converting kinetic energy to mechanical energy. So in hydraulic turbine, shaft connected to synchronized generator. Synchronized generator means what we know, 3-phase AC, all that we know. Converts mechanical energy to electrical energy. In control room, electrical energy is given to transformer for step-up process. So if no power is required to be generated, then we can close the valve. So basically, potential energy, convert to kinetic energy, convert to mechanical energy, convert to electrical energy. Advantage of this is that neat and clean energy resource, and water resources is available. Even in rainy days we can use it. It's clean and neat resource. And disadvantage is high capital investment. It is difficult to transmit power from hilly regions to the localized people. and it all honestly depends on the water, how much water is there, like if rain is coming or not coming, all that also matters. So that was basically sum up on hydro power plant. I hope I have explained well. I think this is not seen. Let me just rewrite. I've tried my best to explain this topic, so hope you have understood it. So see you all in the next one. Until then, bye bye. I've also attached some reference notes in the comments. Check it out if you have any doubts. Bye bye.